All right, welcome everyone. Welcome to the Robofest Online World Championship exhibition event for the junior division. My name is Elmer Santos. I am the Robofest Assistant Director, and thank you so much for joining us today. This is our schedule. Teams, thank you so much for checking in. We'll start with a few remarks, introduce our judges, just give a few instructions to the group, and then we'll get right into the projects and presentations. Robofest is a program of Lawrence Technological University. We thank them so much for their support. And now we have a welcome message from LTU.
Welcome to the 2022 Robofest Online World Championship. I am Dr. Srini Kamampati, Dean of the College of Arts and Sciences at Lawrence Technological University in Southfield, Michigan, USA. This year marks our 23rd Robofest season and our third Online World Championship. We are proud that we have been able to continue to bring Robofest to the world to these extraordinary times, and we will continue to be committed to a competition-based learning environment, however that looks in the future. Robofest is all about STEM learning. Success at Robofest requires the mastery of multiple STEM and computer science subjects, which in turn drives preparation for college classes and high-tech careers. Additionally, Robofest teaches students to develop essential skills such as problem solving, teamwork, creativity, and communication. Thank you for your participation in this online competition. I commend all of the teams and students here for being active learners and pioneers who are eager to master technologies for the future. As you may know, Lawrence Technological University was founded in 1932 with the support of Henry Ford. At that time, Ford's famous Model T factory was at the forefront of an industrial revolution that changed the world. Likewise, we are today at such a forefront of new technologies. LTU and Robofest are paving the way. Someday, I hope you will join us here at Lawrence Tech to continue to do the excellent work you are already doing with LTU's Robofest. Your efforts are advancing science and technology for solving real-world problems. At this time, I would like to thank all the teachers, coaches, mentors, and parents. You make this program possible for our students. Without you, teams do not exist. Additionally, I'd like to thank all of the inspirational site hosts and international directors who have organized local qualifying competitions or are sending teams to the 2022 Robofest Online World Championship events. Finally, we cannot give enough thanks to our local judges and LTU judges and the staff for their dedication. In closing, I wish all of you luck with your endeavors today and hope you have a great connected learning and collaboration experience through our 2022 Robofest Online World Championship competition. Thank you.
And once again, thank you to Lawrence Technological University. And also thank you to Robofest sponsors for 2022. Again, without you, this would not be possible, so thank you so much. The exhibition is one of a series of World Championship events for Robofest. Please join us for our remaining event, the game competition, in 2 weeks. And then our closing ceremonies and awards will be on May 21st. Once again, my name is Elmer Santos. I am the Robofest Assistant Director. Also with us this morning is the Director of Robofest, Dr. Chris Cartwright, Shannon Polonis, Robofest Coordinator, Pam Sparks, Robofest Coordinator. So thank you so much. And welcome to all our teams. We've got 6 enthusiastic teams that have had to work very hard to get their projects ready for today. So thank you for joining us, teams. And next, I would like to introduce our judges. We've got 4 judges for today. I will stop the screen sharing and then we're gonna bring up each judge. Okay, we'll start with Mr. David Carberry, PE.
Good morning. My name is Dave Carberry. I've been involved with Robofest for several years as a coach and a judge, and currently work at Fanuc Robotics in research and development group for industrial automation, and am a graduate of Lawrence Tech, and can't wait to see all the unique projects we got here today.
Yeah, thank you. Next up, we have Mr. John Rezner.
Hello, everybody. My name is John Rezner. I've been doing judging for a while with Robofest. I'm looking forward to seeing your robots, and good luck to everyone.
Thank you. Next, we have Professor Destiny.
Hello, everyone. Good morning. My name is Destiny. I'm also from the Department of Maths and Computer Science, where the Robofest engine resides. And I'm looking forward to an interesting competition today. Thank you to everyone.
Thank you. And finally, we have Pam Sparks.
Hello, everyone. My name is Pam Sparks. I've been a Michigan educator in STEM for over 30 years. I am on staff with Robofest. I'm a huge fan of Robofest, and I have coached teams. I'm also a huge Great Lakes advocate and enthusiast, and I am helping build a zoology STEM pathway on the Detroit River right now. And I'm so excited to see all this innovation today.
Thank you. So thank you once again to our judges. More information on their judges are available or will be available on our World Championship page at robofest.net. Okay, just before we get started, I just want to go over this just so everyone knows the background. Teams were required to provide videos as well as code. So thank you so much, teams, for submitting those. There's going to be a code inspection to recommend points so that those programs will be viewed in detail. Judges have been selected by Lawrence Technological University Robofest office. Okay, at this event, we will give the microphone to each team. Each team will then have 4 minutes to present and demonstrate their robots. Afterwards, judges will ask questions for 2 minutes. Teams must use English for communications. However, translation is allowed where needed. Also, judges may ask additional questions by email after the event within 24 hours, and then teams have 24 hours. Since this is over a weekend, I think we'll give teams a little bit longer to answer if there are follow-up questions. Okay, I think we're at the point we're ready to get into the presentations. Shannon, you want to give us the guidelines?
Sure. What I'm going to do now is I'm going to move all of the teams except the first team. The teams are going to go in order of their team ID. So the Delphinians will go first. Everyone else will be brought back to the seats. So quote unquote, this part of the webinar where you cannot interact at that time. So when it's your turn then to present, we'll bring you back in to the panelist side and move the team that just is finishing up into the attendee side again. So basically we'll bring you up on stage, and when you're done, you're going to go back to the seats. So everyone else will be watching on the attendee side. And if you have any questions or concerns, please type something in the chat. When I advance you to participant or to panelists, you might have to click an accept button. I'm not sure, but also as far as the timing, I will be setting a 4-minute timer, and that will be present in the presentation. And I will also say time's up when your time, the 4 minutes is up. However, if you're just about ready to finish, go ahead and finish. We'll allow 30 seconds on either side, that's fine. But please, at the 5-minute mark, I will give you a hard stop because we do need to go into the Q&A session.
4 minutes.
Well, at 4 minutes, I'm gonna say time's up.
I see.
Then
I see.
5 minutes, if you're still talking, I'm gonna cut you off.
I see. Thank you. Yeah, sorry. Yeah.
Yeah. So, I mean, I will allow the teams to finish up their points if they're, if at the 4-minute mark, but I would prefer that they not go any further than 5 minutes, if they can help it. So at 5, I will start the Q&A at that time, and then we'll try to do a 2 to 3 minute Q&A. But again, if we get a little long there, we will follow up questions with emails at that point. So let me turn on the screen for the timer. And I'm going to set presentation 4 minutes. And so how this works, when you start presenting, I will start the timer. So I'm going to say, whenever you're ready, you may start, but I will start that 4-minute timer when you start talking. So you may start your presentation.
Hi, my name is Marcel Gunn, and this is my piano for dolphins. The reason this piano is for dolphins, since pianos need to have the need to express food and need for food and water, and this piano might help with that. So I went into the code, and as you can see, it goes from 0 all the way to 2. And there are 3 main functions of this piano. The first function is the recording function. If I press this button right here, then the playback function is now on, and now I can press any note. And if I turn it back off, I can press the playback button. And it plays the notes back. Now, if you want to delete your recording, it's very simple. Just press this big button in the middle, and you can either select yes or no. So I'm going to select yes. So now I'm going to go into code to teach you how this works. So as you can see, this is the code for deleting the recording. It says all the values to 0, and then if not, then it does nothing and just clears all the rows. This is the list for recording, and under that is the list for playback. It plays do for the first note. It plays do for if the note and the value in the recordation is 1, re for 2, mi for 3, and so on and so forth. This is the function that plays notes, and also under it, it checks if the player is recording or not. And this goes on for the rest of the code. Except the final one, that is the one where if there are 5 notes on the brain, it gets rid of all of the line. The next boss will be a food bot, in which will dispense the food to the dolphin. It will follow the line, dispense the food, and then turn back. There's a mind block here, and basically what it says is it just makes the food bot follow the line, and then when it sees the dolphins, then it will dump the food, and then we'll go back. So now I'm going to go food bot. So I'm going to go for the food bot. The light level is 100, so I'm going to press this touch sensor. Speed up to the dolphins, and now it will turn around. And so the process, then it will stop. Both these robots correlate to each other and will easily help the dolphin. Will help the dolphin survive and live its best life. Yeah.
Are there any questions from the judges?
I have one. So as a biologist, I'm super interested in this project. When would it be a good time to artificially feed the dolphins versus having them just feed off of what's naturally there? You know, like when you go to the Detroit Zoo, they say don't feed the birds. So when would it be an appropriate time for a robot to feed a dolphin?
Okay, so basically what will happen is that the dolphin will play a certain melody, and if the trainer hears that melody and knows that, it'll send out the food ball.
So this is for dolphins in captivity.
Yeah.
Thank you. Very nice project.
Any other questions from the judges?
Yes, I've got a question. How long did it take you to program this robot, and did you have any challenges during the programming phase?
Okay, so the piano bot took around like in total 2 days, mainly to add the recording function, and for the food robot it took like a day, like less than a day, since it was really just a line flowing.
All right, thank you.
David, go ahead.
Right, you've got two CPUs there. Do they work together or are they completely separate?
Yes, they do work together. So basically, so if the trainer hears like a melody from the piano bot, then it can easily send out the food bot.
So what inspired you to do dolphins?
I mean, so I did remember before that dolphins are very intelligent creatures, and I thought that, you know, since they can like learn different melodies to like express needs for food and water, so that's what I thought. So that's what I thought. That's why.
Hey, very nice. Good job. Very nice.
Thank you. That's the end of our Q&A session. We're going to bring in the next team from Detroit Country Day Middle School, the team 3122-1, Walls. So as soon as the team is ready to start their presentation, I will start the timer.
Hi, I'm Qasim. I'm Ali.
I'm Lyle.
I'm Levi. And I'm Zohair. And this is called City.
These are the power plants for the city. We have both hydro and wind power. The hydro power is affected by the river speed, which is governed by a linear equation that transfers 255 to 100 to convert the speed of the river from dial position. The wind power is controlled by a sound sensor that detects the wind and increases. Yeah.
Here we have the solar panel. It uses a light sensor and tells servos what to do with the amount of light it receives. So if we take the sun and let it rise, everything moves accordingly, maximizing efficiency.
This is the stadium, and it works with a microbit as a jumbotron, and the NeoPixel as a light. It's called the Ready Center. And when you click the A button, the lights turn on, and a team, well, this is the Spartans, it displays across the jumbotron, and then the colors of the team correspond with what is being displayed.
Transportation is a big part of our city, so we made a rover. Instead of making a traditional train that follows tracks, we made a rover that follows a black line. We did this by adding a light sensor and an LED under the rover. Because black absorbs light and white reflects it, the light sensor will pick up the amount of light that is projected by the LED and then will follow the black line. We also have a sensor in front of the rover. In case a pedestrian somehow stumbles onto the track, the rover will detect it, stop, and make a beeping noise. Once the pedestrian's gone, the rover will continue. Also, for accessibility reasons, we added a dial on top that turns the rover on and off. Okay, so this is our city, or our buildings. They're 3D printed and modeled by us. In the buildings, there are LEDs that light up. They light up because they're powered by a box, this box. The box has a light sensor on it that's coded so that when it is dark, when it is dark, the buildings light up. Thank you. Thank you.
Thank you. Let's start the judges' questions.
Could you tell me how many different CPUs you have and what programming languages are used?
We use make code for programming, and we have about 6 different CPUs. And we use microbits and hummingbirds.
So did you divide yourselves up into like teams to work on the various parts, or did you all work together?
Yeah, so what happened is when we started, we kind of set like different people who were good at different things. They built what they were good at. So like Levi and Lyle, they contributed to the river and the wind, and I built the rover. And yeah.
And my second question is, how practical do you think these technologies are to implement?
Say that again.
So how practical is it to implement this?
I think when we first built this, we knew we didn't want to make like an ordinary city. We wanted to make stuff unique about it. Our main goal was to make like an eco-friendly city. Hence the reason for like a black line in the wind. So I think if like more and more cities implemented different like eco-friendly things like the windmills or hydropower things, I think that would overall like contribute to green things like that.
Okay, nice.
Any additional questions?
Could you just go over to your model? And could you just show us each component again? So you had the sun, and then
So yeah, here's a light sensor so that when the sun comes up, there, it turns accordingly, so that the sun is always facing the solar panels.
So this is the wind and hydro powered portion of the city. So on the back of the hydropower plant, we have 2 dials. So one dial governs water, and one dial is just a shut off for the wind, so that we can stop it if we need to. And then this has a sound sensor in it, so that when you blow into it, it increases the speed of the windmills. And then in the back of the river, there's a microbit and a neopixel that creates light.
So for the stadium, all you do is click the button and it changes. So once this finishes, it changes the team and the lights. Yeah, okay.
And then the rover right here, there's a light sensor and LED, and because black absorbs and light deflects it, it can follow the black line. And then there's a distance sensor in case something comes in front of the rover, it would stop and not hit it. Then the buildings, right? So they're 3D printed and modeled by us. They have LEDs inside them, and the LEDs are connected to a hummingbird controller in here. And on the top of the building, there's a light sensor, and it's coded so that when it's dark out or you put your hand on it, simulating what's nighttime, the lights turn on. So it's like eco-friendly. It's like the lights aren't on during the day.
All right, we have to move on to the next team, but thank you, judges. If you have any additional questions, please, we'll send them to the team via email. So at this time, we're going to bring over 3991-3. Congratulations, team, you did great. The team from Tampa, Florida, the Python Pirates.
Okay, hello everyone. Can you guys hear us? Can you see us?
Yes, we can hear you.
Okay, just want to make sure the camera is positioned in a way that you can see everyone.
Perfect.
That's good. Okay.
All right, let me reset the timer for the 4 minutes. Whenever you begin your presentation, I will start the timer.
Can you stop now?
Miss, speak up because you're far away from your microphone, so make sure you can hear you.
All right, we're all ready.
Okay.
Are you ready, girls?
Can you?
Just 2 seconds. Just setting up the volume.
Okay.
Okay, we're ready now.
Go right ahead.
The scenario is inspired by everything that's going on in the world right now. War and destruction. Pyrite, which is our robot, will proceed to maneuver over the obstruction and will extract the reusable materials trapped in the obstruction along with the toxic waste. The purpose for Pyrite to complete this is to make it safer for first responders to attend the surrounding area. After extracting the reusable and toxic materials, Pyrite will sort each element into 2 different sections. This will help the authorities even further. Pyrite will proceed to make a rescue and recovery cleanup of tons of wreckage quicker and more efficient. For Pyrite to complete this task properly, our team decided to build the Plus model, which will handle the job the best of all the models. Pyrite uses a complex block code, which is run by Python. When we're constructing a specific scenario, we purposely decided upon this scenario so we could show the potential of future robots like Pyrite in helping the work industry. We believe that the superlative way to show Pyrite's abilities is by showing the robot's capability of being applicable and saving its full potential. Again, this scenario is inspired by everything that is happening in the world right now, with all the war and destruction. Pyrite is fixing everything humans have destroyed and restoring peace in the world. Thank you. Thank you. As we said before, the type of code we used was block code, which based itself mostly off of Python.
Can we do a screen sharing of the code?
Yeah.
Are we allowed to do that?
Sure, go ahead.
Yes.
So this is, we have 2 codes. So this is the Python.
This is for Pyrite. And so as you can see at the beginning, what we tried to simulate was inside the Glorasper, which moved the cubes, we put a sensor so that every time it found an object like the cubes with this specific weight, it would close the grass and proceed to move in the direction we named on the left side. So what we used here was millimeters to be more exact. And then as it went on, we used different types of degrees. We use different degrees, although we try to make it mainly 90 degrees so that the robot will have the best angle towards the blocks. Now for the other robot.
We have a second code, so I can show you the second code. Okay, this is for the other robot that is charged of demolition.
So what I did with this code was with the start function, I allowed it to be free move, which allowed the chassis to move separate from the head to move without the chassis move. That allowed it to fit its target successfully. Then I adjusted the gimbal speed, which change the speed that this is moving at, so it can hit the targets, or sorry, gimbal angle, so it can hit the targets fast and accurately. Now, I enabled Vision Maker, which allowed it to scan the object.
Time's up.
We stop screen sharing, I guess. No.
Yeah. Judges, do you have any questions for the team?
Team, there appears to be a second robot. Does it move or does it just stay in that position?
Well, it can move, but we've designed it for the specific purpose of hitting its targets. So it's not moving, it's only shooting.
Okay, so that second robot is the one that knocked the buildings down?
Yes, yes.
Ah, okay, thank you.
Can you tell us more about the rest of your set? So it looks like a lot of work went into setting that up.
Okay, so basically what we thought was, how we have a lot of problems in the world right now, and there's been a lot of destruction left behind, and we thought we would make a useful robot, right, to help that. And for that purpose, we basically set up a city, as the many cities that have been destroyed, so that you could see the robot working in a scenario and maneuvering around different objects.
Very nice. I love your poster back there too. Very creative.
Thank you.
Any additional questions?
Yes. So you've got a large team. So how did you guys divide up all the work for this project?
So we started by dividing ourselves into two groups, the ones that were building the scenario and the ones that were working on the robot. Then we went on to each group. We saw that we needed more help in building the scenario since it took a lot of craftsmanship and imagination. So what we did was, you see this 4 ladies right here started working on the scenario, and us 3, what we did was we divided between building the robot and coding for the robot, the 2 different robots. Him starting coding for the second robot, I'll code for the first one, and she built the first one, so that everybody could have an equal amount of tasks. This girl over here finished our poster so that we could have a nice scenario to show you guys, and they focused on building all the buildings around and the trees.
Alrighty. Thank you. So how long did it take you to build your robots and the scenario overall?
It took us, this robot here took about a day to build. It had a fairly straightforward building, but wiring was quite difficult to figure out. This robot over here took us about a week to build, but that was with other inconveniences. And the scenario, it took them about 2 days to build, including with the banner, so that we could all set it up in time.
Alrighty. Thank you very much.
Thank you, judges. And next, we will bring in a team from Saudi Arabia, Intelligence of the Future. Give them a moment to turn on their camera, get settled. I'll reset the presentation timer to 4 minutes. If you have another device in the room that's logged into the webinar, please turn off the speakers and microphone on that other device. That will eliminate the feedback.
Yeah, sounds good now.
Yep. Okay, whenever you begin, I will start the timer. You may begin.
I'm here to translate, and we will begin now.
Thank you.
Salam. Hi, Judge. We are the Power Factory of Good Starting. We are the future innovator team. My name is Nana. My name is Farah. My name is Sidin. My name is Maria. The main problem is failing to delivery orders to the customer correctly. To the customer correctly due to wrong input data and addresses. The purpose solution is to design a system to classify customer orders by color. Each area in the city will be assigned to a specific color. So when the driver picks the orders, he will know the correct area. The requirements material are 1. Smart device, 2. The motor, 3. Lego blocks, 4. Sparking device, 5. Video device. طريقة نقل بضائع قديمة باستخدام الطائرات والشاحنات ويأخذ المندوب البضائع وضعها إلى الشاحنة وهذا يسبب جهد ومشقة للمندوب وتتأخر وصول الطلبية.
The old way of goods transportation was done by using airplanes and trucks, where the driver has to take the orders from the airplane to the truck, which incurred a lot of effort and time consuming, resulting in late delivery of the customer's order.
طريقة توصيل البضائع حديثاً باستخدام شاحنة الروبوت بحيث تصل البضائع إلى منزل العميل بسلاسة وسهولة.
And now we developed it by using a robot truck in the easiest way.
عن طريق الذكاء الاصطناعي تم التطور عن طريق الهليكوبترات. تقع البضاعة في الحاوية عن طريق البرمجة.
Through artificial intelligence, the drones will place the orders to the truck based on their direction via programming, and then the truck will take them to the sorting center.
وتأخذ الحاويات البضاعة وتذهب. أما حديثاً قمنا بتصميم نموذج روبوت بحيث يكون لكل حي لون، وعندما يرى مندوب اللون سيعرف الحي ستوصل طلبيته للباب المنزلي، وسيكون مثلا اللون الأزرق للجنوب واللون الأخضر للشمال.
The sorting center will organize them based on their color. For example, the green color for north and the blue color for south.
ستأتي الشاحنة الأولى وتأخذ البضائع الخضراء وتذهب للشمال، وتأتي الشاحنة الثانية وتأخذ البضائع الزرقاء وتذهب للجنوب.
As you can see, the first truck took the green orders to the north, and the other truck took the blue ones to the south.
من خلال التطور توصلنا إلى الأرجوحة بحيث يضع المندوب البضائع على حسب الاتجاه الذي يتجه له، وتدور الأرجوحة إلى اتجاه العميل ويأخذ البضائع ويتجه للاتجاه الذي يتجه له.
And we have developed a swing machine to help the driver to help the driver in placing the orders to the required direction and area.
بفضل من الله اكتشفنا الكثير من المعلومات والمهارات والتوجيهات عن نقل البضائع.
We have learned a lot of information and knowledge about transportation system across all means.
نحن نستمع إلى أفكار بعضنا كفريق واحد تحت شعار واحد لنشعر بالمسؤولية كفريق بفضل من الله قد أنجزنا من المهام كيد واحدة.
We took full responsibility as one team, and finally, we have achieved our tasks and goals.
نحن نستخدم الإبداع مع بعضنا لحل المشكلة مع بعضنا وأهلنا كفريق مسلم.
We use creativity in our works as a creative team.
قال رسول الله صلى الله عليه وسلم المؤمن للمؤمن كالبنيان المرصوص يشد بعضه بعضا. تعاوننا أنا وفريقي كيد واحدة في كتابة المشروع وتصميم البرمجة الذي يخدم نقل البضائع.
We are strong. We work together, as Prophet Muhammad said. A believer to another believer are like building with different parts reinforce each other.
موهبتي سر تميزي، التميز مسيرة عطاء مجهود وعناء من البدايات الصعبة والأثرات القوية إلى النهايات الناجحة. كلما كان هناك تعاون أكثر كان هناك نجاح أكثر. We are one team. We are one team.
Thank you. Judges, do you have any questions for the team?
Could we get the translator to walk us through the highlights of the poster?
Oh, here's the problem and the solution and the material. And here, this for the work team, and this for creative, and this for fun, and this our a picture for them to this picture while they were working. And that's it.
Thank you.
So your project addresses a really important need. How does your project like improve transportation? So how are you better than Amazon?
كيف المشروع بنفسه؟ كيف المشروع بنفسه وليش هو أحسن من أمازون؟ ارفعي صوتك اسأليني السؤال انت. اسأليني المشروع. كيف المشروع يثبت نفسه؟ ليش المشروع كويس؟ ليه أنت شايفه المشروع كويس؟
لأنه لتسهيل خدمة فرز البضائع بحيث تصل الطلبية إلى باب منزل العميل بدون أي خدوش أو تكسير أو أغلاق. ويساعد المندوب على توصيل الطلبية بسلاسة وبدون خطأ في الموقع.
Because this will make the orders arrived safe and help the one who deliver this and help them. Yeah.
Okay, nice application of a real problem. Well done.
Thank you. Thank you.
Are there any additional questions, judges? Or we're going to move on to the next team. The next team is 4280-1, and they've got several devices, so we're going to bring them over. I think we got them all. Let me see. Nope, one more. Do we want to spotlight them, Elmer, or I think when they just, if I put them on speaker view, they'll kind of
We're
guide them.
spotlighting the two
The
main
two,
cameras.
okay.
Yeah, that's how we practiced it.
All right. So I can't find the other one now.
Here I have it.
Okay. All right. All right, when you are ready to start, go ahead and just start. I will start the timer when you begin your presentation. When you're ready.
Good morning. We are 4280-168 Innovative Creators. During the pandemic, we have found different problems at school. Therefore, we have invented the cool pandemic gadgets.
The first problem we found out is that virus could spread through personal items being passed frequently. So we made the smart delivery cards to help the teacher pass things without touching. So this saves manpower and also lessens the burden of the teacher. So the concept behind is if the both sensors in the front of each card senses yellow, then they go straight. But if one of these sensors senses other than yellow or no color, then they turn left or right to sense yellow again and follow each other. There's also one more function, which is if I press this touch sensor, it will bring up the load and to the person without making any contact with anybody. Let's demonstrate now. Let's move on to the next gadget.
Now I'd like to show you two educational games that students and people can play when the pandemic is serious. For the first game, James the Hedgehog needs to clean different objects in the house using the correct cleaning tool. You can switch the cleaning tool by pressing 1 or 2. If I clean an object wrongly, then I will get score deducted. There is also a virtual pet to see how you are doing in-game by showing a face depending on how you're doing. This game can teach us how we can clean different objects correctly. For level 2, James the Hedgehog needs to chase students who are not wearing their mask properly. It is also quite hard as they try to run away. For the second game, we need to click on the people who are not wearing a mask or not wearing a mask properly, just like a whack-a-mole game. This game can teach us how we can wear our mask properly. That are the games I want to show to you. The final problem we have found is that some students don't wear their masks properly. Therefore, we have made a program called Smart Mask Detector, which can detect if you're wearing a mask properly or not. Our program uses artificial technology in teachable machines. We gathered many photos, and the machine uses the data to recognize our faces. This is the program to give advice. As you can see, my mask is on properly, so it congratulates me. But if I put my mask in properly and reveal my nose, then it will ask me to pull it back on. It can even detect if I'm not wearing a mask.
Time's up.
Is the end of our presentation.
Thank you.
Excellent. Judges, take it away. You have questions?
I think the idea for the video game is awesome for maybe helping younger students learn how to do some of the right things. Where did you get the inspiration for that?
Because only just not just following the measures is important, but also hygiene in the house is also important. So I wanted to teach about how we can clean in the house.
All right, nice job.
Can you tell me what programs you used? Like the video game program?
We use Scratch for the video game, and also Microbit for a bonus. See how you're doing in game.
Oh, okay, so what did you use for your cart?
We use the Lego Spike and Lego Mindstorm for building the smart delivery carts.
Okay, so I would like you to build a cart for my classroom. How long until you can have it ready for me?
We can say about 2 to 3 months.
Or maybe if we need to make it a little bit, more up to scale, then maybe even a whole year.
Right, so maybe you can improve on that. I think teachers really would love the help in the classroom. Great idea. I'll be your first customer on that one, okay?
Sure. Thank you. Thank you.
Thank you. Okay, at this time, we're going to bring in our final team, 4282-1. Typo Old Market G2. Thank you for raising your hand. I'm going to reset the timer to 4 minutes. Whenever you are ready to begin, I will start the timer. Restart.
Hello, ladies and gentlemen. We are Caprio, Angus, and Shut Up. We come from Hong Kong. Our team ID is 42821. We study at Typo Old Market Public School. Today we are going to show you our robot helper. It can help collect the assignments for the teachers. We hope the help of the robot can show teachers our care and respect. Now it's time to demonstrate. This is the teacher panel. This time the teacher wants to get the green assignments, which is the left button. Now the lifter is heading to the green assignment submitting area. Oh, it looks like the students didn't submit their assignments, and the lifter will voice out.
Students, please submit your green assignments.
So how do you make it work? First, we have the teacher panel. Remember when the teacher presses the left button, which says as green assignments, then the windmill will rotate the green block accordingly to the south. Then we have the backward color sensor to read the green block, and the lifter will move. When it moves, the downward color sensor will read the color spot and turn. We use shot angle from gyroscope, therefore allow an accurate turning. Finally, when it reaches the assignment rack, it will detect 11 cm or less. Then the lifter will stop moving. Also, when it detects 9 cm or less, it will lift up and move. Otherwise, it will voice out asking for assignments. Okay, now the students are ready to submit their assignments. Now the lifter is heading to the green teacher collecting area. When it arrives, it will also remind the teacher to get the assignments.
Dear teacher, here are the green assignments.
Now the lifter is heading back to the starting point and is ready for the next mission. The second mission is to move the red assignments, which is the right button. Now the lifter is heading to the red assignment submitting area. Oh, it looks like the students behaved themselves and have already submitted their assignments. This time the lifter has no time for coffee anymore, and it starts moving them to the red teacher collecting area like before. Now I'll pass the time to Caprio for a hardware introduction.
Thanks. The design of the robot helper simulates the industrial forklift truck. We use broad gears and spur racks to convert the motor spinning motion to vertical lifting. Then we built a lift shaft to fixate a lifting stand. At last, we put some weights at the rear end to balance the lift. This is to prevent the lifter from tipping forward. And now the lifter is light and stable. Now it's time for Angus to do the conclusion.
In conclusion, we can make use of the newly invented heart-to-heart communication technology to create the robot helper, along with a variety of robots, can be further modified to provide coordinated service, such as collecting and distributing all kinds of homework. We hope you like our ideas. Thank you very much.
Thank you.
Yeah, nice job, team. In the display, you have a classroom setting, and there is the boards. Do those boards represent pieces of the project? Or is it just a typical classroom board?
Actually, we use the plastic board because when it turns, and it will not be very accurate, because the floors the friction is if it's too high, then the turning won't be too accurate. So we added the plastic board so the turning will be more accurate.
That's good information. I was asking about the board in the classroom, the background behind the desks.
Oh, those are the decorations.
Okay, so that's not details on your project. I just thought it would be quite clever if you had details on your project in your project. All right, great job, guys.
Thanks.
Any other questions?
Yes, I've got a question. So what was probably the hardest thing for you guys on this project?
I think the hardest part is how to turn the model spinning motion to vertical lifting. Then we found out using some spur gears and spur racks can solve the problem.
All righty, thank you.
Thank you.
So what would happen if the robot stopped working, like in the middle of class? How would you solve that problem?
Actually, we won't have this thing to happen because like in a few weeks, we tried a lot of times and we found out all the problems and solved it. Like one problem is the turning one, and then we figured out using a plastic board and using the yaw angle can solve the problem.
So what do your teachers think of this idea?
I think the teachers think this is a very great idea.
Well, I think it would give teachers a better chance to have coffee, like you said.
Yeah. Yeah. Yeah.
So very nice job. Excellent teamwork.
Thanks. Thanks.
This concludes the presentations.
Okay, thank you very much, teams. I think it's time for to wrap this up. Yeah, once again, teams may receive follow-up questions by email. And as I stated earlier, since it's the weekend, we'll allow a little bit of extra time, probably to the end of Monday, if you receive questions. So if teams do not receive questions or have questions, if the judges do not have questions for the teams, we will also let them know that. Results, I know you're probably anxious to see how you did, but you're going to have to wait a little longer. The results will be announced at the Robofest Online World Championships closing ceremony on Saturday, May 21st. So please join us for that. Okay, I think it's time for the closing. I'd like to introduce Dr. Cartwright.
Thanks, Elmer. So I'm Chris Cartwright, Director of Robofest. Thank you everyone so much for your participation in this online format of Robofest competition using real robots. I'd like to thank all the coaches, mentors, parents, students, and judges. Special thanks to our Robofest staff, Shannon, Elmer, and Pam. I was impressed today by all of the creative applications of robotics to solve various problems, again, that affect our daily lives. Again, like interaction with dolphins, and renewable energy for smart cities, disaster relief, again, helping fix up, demolished buildings, and removing, rescuing people in war countries, delivering food autonomously, artificial intelligence to promote health and safety, and also, for instance, like robotic delivery to alleviate some of the tasks of humans, like teachers. So again, I'm really impressed by all the projects today. Everyone deserves a round of applause. And I hope to see everyone on May 21st for the closing and award ceremony. Thank you, everyone.
Thank you, everyone.
At this time, we're going to end the webinar. Good luck to all of you. We hope to see you again very shortly at the World Championship Award Ceremony. I will be sending out links to the ceremony. Please invite your family and friends to join us on that time, May 21st at 8 a.m. Eastern Time. We'll see you then. Take care, everyone. Thank you.
Have a great
Goodbye,
weekend,
everyone.
everybody. Goodbye.
Bye.
Bye. Have a good day.